types of velocity. So number one type which we have is known as uniform velocity. So what that means? Velocity means that body covers each time that is known as uniform velocity. Right now let's look at the uniform velocity. One thing you can do that the graph will have displacement time graph, that is known as displacement time graph, which is this. So look at this, basically the graph of velocity. Let's zoom into this so you can easily understand. Okay. So for the basic rule of the graph is to that x-axis a quantity will come which is independent, right? So on x-axis we put time because it is independent, right? And on y-axis we'll put a quantity which is dependent. Displacement is basically dependent, right? And time on the x-axis. So when we talk about uniform velocity, it means the body covers equal displacement in equal interval time. For example, displacement 1. So 1 displacement covered by body in 1 second, right? 2 2 meters covered by a body in 2 seconds. 3 3 meters covered by a body 3 seconds. So it means that it is in equal distance and equal interval of time, right? Right. So the when will join a straight line. So this graph basically shows us the uniform velocity, right? So I hope is clear to you. Okay, this type of velocity which we have, which is non-uniform velocity, which is non-uniform velocity. What does that mean? Basically, when a body does not cover equal displacement and equal interval of time, that is known as non-uniform velocity. When a body does not cover equal displacement and equal interval of time. For example, let's look at the graph of this. Okay, this is basically the graph of non-uniform velocity. Okay, so non-uniform velocity graph can be anything. For example, it can be like this too, right? Even though it can be like, let me make this. So it can be like this too, right? So this is a graph of non-uniform velocity. It can be any type. For example, it can be like this too. Even though like this too, it can be of any type. That is, the graph is known as graph of non-uniform velocity, right? So now let's look into the instantaneous velocity. What is that now? So these are also graphs. This is a graph of uniform velocity and this is a graph of non-uniform velocity, right? Okay. Now let's look into another type, which is instantaneous velocity. What does that mean? Velocity at an instant point. Now, for example, you are driving car and I've called you that, hey there, what is you are going somewhere, so what's your velocity? The velocity that you will tell me at that point, at that instant, it is known as instantaneous velocity, right? So velocity at an instant point is known as instantaneous velocity. So here actually time interval is very small. Time interval is displacement covered body in a very small interval of time is known as instantaneous velocity. So the condition over here is that the time must be reached to, like time will be approached to zero. Time will be zero. You can say the time will be approached towards the zero in this. So when we look at the graph of, like, we don't have certain graph instantaneous velocity. In this we find slope. Now what is slope? The formula of slope is basically y2 minus y1 upon x2 minus x1, right? So for example, this is the graph of uniform velocity and this is point A, this is point B, and this is point C. And for example, let me make it again. Okay. So for example, this is a graph of uniform velocity, right? And here I have certain points. This is point A, this is point B, this is point C. I have named them A, this is basically B, and this is basically C. So I want a displacement, like I want this velocity between these 2 points. These 2 points. Now how I will find? I will find with the help of slope. Now I want the slope between point B and C, right? For example, okay, here we have, okay, So you can see over here, slope. Slope, the form of slope is y2 minus y1 upon x2 minus x1, right? So here y2 is basically this 3, y1 is 2, right? If you see, oh my god. As you can see, this is on number 2 and this is on number 3. And x2 is basically on number 3. Oops. And y2 and x1 is on number 2. So when we divide, we'll get 1. So answer of this basically graph of uniform velocity will always be 1, right? It will be always 1. Now we have another graph of this, which is, okay, here we have a graph. Okay, for example, we have now graph of zero velocity. We have the graph of zero velocity. What happens that velocity is not covered. Now what will happen? It means that displacement is constant over here. The like time is passing by, but the displacement is constant. And what is velocity? Change in displacement per unit time is known as velocity, right? We have studied this in my previous video. Now there is no certain change in displacement, so it means there will be zero velocity. So this is known as zero velocity graph. So in this graph, basically, in this graph, the straight line is parallel to time axis. It will be parallel to time axis. It is parallel to time axis, right? Okay, note there is one more thing to note for emphasis purpose, which is that if uniform velocity and instantaneous velocity both are equal, then the body is in uniform motion. If a body has uniform velocity and instantaneous velocity, the value of both these velocity are same, then the body is said to be in uniform motion. We will study this uniform motion in Newton's first law of motion. So whenever body is in uniform motion, it means that its acceleration is zero, right? So here, if acceleration is zero, then if we find formula which is F equal to ma, then mass is there, right? But acceleration is zero. Mass into zero is zero. It means whenever there is uniform motion, the net force is zero. The net force is zero. So I hope this lecture is to use any kind of queries in our comment, and I would be very glad to answer you guys.